So the setup for this question is that the individual receives utility both from the amount of C that they consume, the amount of S they consume, but they receive a form of disutility in the amount of S that others consume. So S bar meaning the average amount of consumption of S by other individuals. And so what we want to be able to do is that's our utility function. We want to now set up a Lagrangian for this. So we get the log of C plus log of S minus 1/2 the log of what other people consume plus a typical budget constraint where we get minus the price of C times C, the price of S times S. Now notice in this Lagrangian, in this optimization problem, S bar isn't our choice. So we're not optimizing with respect to S bar. We're maximizing, let's keep that in the same color. We're maximizing the things we get to choose, which is C, S, and lambda. And so when we take our first order conditions, with respect to C, we get 1 over C minus lambda PC equals 0. Our first order condition with respect to S is 1 over S minus lambda PS is equal to 0. And now we get our third order condition, which is our budget constraint, which is I equals PCC plus PSS. Notice now that our first order conditions are not a function of S bar, even though it enters into our utility function. So the individual is going to optimize, and here's where we're going to get our optimal amount is C star for the individual will equal income over 2PC, and S star will equal income over 2 times PS. And now we can look at, well, if this is for the representative individual, well, then we know every individual is going to make the same decision such that S is going to equal the average S of each individual. And that's going to be helpful for now when we look at our utility function. The utility of this individual is going to equal log of C star, which is I over 2 PC, plus log over S star, I over 2 PS, minus 1/2 log of S bar. But we said that S bar is the same as S since every individual is a representative individual. Therefore, we would get 1/2 log I over 2 PS. So we can then combine like terms, and this will be our U star is going to equal the log, and now this is going to look a little ugly, but we can handle ugly. I to the 3/2, because we have 3 different I's. Oops, we erased that. And then we have this 1/2 here in each of these, so we can bring that to be able to get to I to the 3/2. I'm sorry, that 1/2 is going to come in right now, of 2 to the 3/2 PC times PS to the 1/2. And so that's how it simplifies into the individual's maximum utility. So that's for the individual. Now we argue that there's a negative externality here with this consumption of others. So is this the amount that is socially optimal? Well, let's look now at what the central planner would do. So in this case, the central planner is going to maximize C1, C2, so on and so forth, S1, S2, so on and so forth, and lambda. So they're going to try to choose all the consumption levels of each individual to maximize joint utility. So that's going to be the log of, now we're going to add up I equals 1 to n of all the individuals, natural log of CI plus natural log of SI minus 1/2 natural log, of S bar plus lambda income of individual I minus PCCI minus PSSI. So that's the optimization of the individual, or of the social planner rather. And so we can look at this and calculate this accordingly. This is equal to 1 over n times log of C1 plus log of S1 minus 1/2 log of S bar plus 1 over n times log of C2 plus log of S2 minus 1/2 log of S bar plus, and we keep going there. And now we're going to add our budget constraint, which is all the individual incomes minus PCC1 minus PCC2 minus so on and so forth, and then the minus PSS1 minus PSS2 minus so on and so forth. So that's where we break apart that individual, those individual, or break apart the summation into individual components. But now we know that each individual, now we're going to impose that S1 is equal to S2, which is equal to the average consumption of each person. And so now we can rewrite the objective function is that we're going to maximize our Lagrangian, which is log of C plus log of S minus 1/2 log of S plus our budget constraint. Where we'll get I minus PCC minus PSS. And now we see that since we have this S and this S the same, we will then get log C plus 1/2 log of S plus our budget constraint. And now we can take the first order conditions of the socially optimal amount. So with respect to C, we get 1 over C minus lambda PC equals 0. And now here's where it changes. When we take the partial derivative with respect to S, we get 1 over 2S minus lambda PS equals 0. And then we get our third first order condition with respect to lambda, which is our budget constraint. And so now when I solve for the socially optimal amount of C, I get 2I over 3PC. And the socially optimal amount of S is equal to I over 3PS. Now, if we compare that to what we had before, is we see it's a different amount. Specifically, it's a different amount of S that's being consumed. And that's oftentimes the argument we say is that without externalities, individuals consume too much or more than what is socially optimal. Now, lastly, we can look to see the utility that an individual receives. So we'd plug in these numbers to be able to get the socially optimal amount of utility. is going to equal the natural log, and here's where this one's going to get gnarly, but we can handle gnarly, income over 3/2, 2 to the 3/2, PC PS to the 1/2. And so now we're going to compare this utility to this utility, and they're the same except for this term. And we'll see is that we get over here, we get 1 over 2 to the 3/2. And over here we get, the socially optimal amount is going to have and so when we look at our utility that's socially optimal, we will get the log, and now this is where it's going to get gnarly, but we can handle gnarly, 2 times the income to the 3/2 over 3 to the 3/2 PCPS to the 1/2. So that's our utility for the socially optimal individual. And so this is where now we compare the utility of the individual maximizing their own personal choices, and then the utility of the individual who's internalizing the externality. And one thing we note is those look very similar. The socially optimal has 2 over 3 to the 3/2, and the other one has 1 over 2 to the 3/2. Otherwise, they're exactly the same. And if I solve these out, what I'll see is that this is 0.385, which is greater than 0.354. So the utility by internalizing the externality is going to be greater than the utility of the individual acting in their own best interest.